The quadratic formula is just another way to solve a quadratic equation. All right, so the ways that we've already gone over, the ways that we've learned, we can solve by factoring, where that's the easiest. It's our most direct way to do it. We can solve by completing the square, which is what we did yesterday, and I'll go over a couple of examples. And then we have the quadratic formula. Okay, so when you are solving with the quadratic formula, this works for any quadratic equation. Works all the time. What does it mean if it's a quadratic equation? What's the highest exponent? 2. Okay, good. Well, Mr. Saldana has right here. You must have this memorized. So here you guys go. If you go on YouTube, there's like a million quadratic formula songs. I know that sounds cheesy, but sometimes if we listen to it and it gets stuck in our brain, it's an easy way to remember it. But when we're using the quadratic formula, what you have to really, really, really remember and focus on, guys, is that your quadratic has to be in standard form, set equal to 0. Because if you don't have it in standard form set equal to 0, the signs won't be right on your numbers, or you might have the wrong numbers, meaning A in the formula is the number that is in front of x squared. B is the number that's in front of x, and C is the constant. So it's really super duper important. Put everything in standard form, set it equal to 0, and then you can use that formula. If you guys don't have this memorized, just take a picture of it, and then next to every problem that we do, just put it next, and you'll start to, the repetition will be beneficial. All right, so let's look at number 1. We're going to do all these together quickly. First things first, right? This is not going to factor. If you ever have a question that just says solve, and it's a quadratic, you should always try to factor it first, but these ones aren't going to factor. They're telling you to use the quadratic formula, so that's what we're going to do. Is your quadratic in standard form? Is everything on the left-hand side, your exponents are in descending order, meaning x squared x and then no variable, and is it set equal to 0? Yes. So your A term is the number that is in front of x squared. So A equals 1. Your B term is the number that's in front of x, which is 4. And your C term is the constant. What is my C term here? Negative 21. You absolutely, guys, you have to keep the sign that's in front of the number that sticks with it. So now, if you have your formula written down or you have it next to you or whatever, we're just going to fill in the numbers. So x equals, what's the first thing I write in the formula? Negative B. So Michael, I'm going to write negative 4, right? Then what? Plus or minus. Really important, guys. You have that plus or minus, and then we write a big square root. What goes underneath the square root? B squared. So I'm going to say 4 squared minus 4 times what? A, which is 1, times C, which is negative 21. And that's all divided by 2 times what? 2 times 1, your A term. Now again, guys, the quadratic formula, if you know it, it's super easy because all you're doing is just taking numbers and plugging in. And then we're going to simplify. We're going to simplify inside out. So that negative 4 is just going to stay hanging out here. Plus or minus. What is 4 squared? 16. What's minus 4, or negative 4 times 1? Negative 4. Times negative 21. Positive 84. A negative times a negative is a positive. Good. And then all divided by 2 times 1 is 2. For the foreseeable future, guys, you should not get negatives underneath your radical. We will get to that in probably a week or two where you have negatives underneath, and that becomes, we talk about imaginary numbers, but we're not there yet. So check each step. When you first put your numbers in, make sure that you have the correct numbers. Make sure that you have the correct signs. Then as you simplify, as you're going down, right now we should not be getting a negative underneath the radical. So remember, if your B term is negative, when you square a negative number, what happens to that number? Your answer becomes what? Positive. When you square a negative, it becomes positive. So just remember little stuff like that. So now we're just going to keep simplifying. I have negative 4 on the outside, plus or minus. What is 16 plus 84? It's how much? 100. Okay, so square root of 100 all over 2. Can I simplify anymore? Yes. Yes. What is the square root of 100? It's 10. So what we have here, guys, we have 2 very simple math problems. I don't have any radicals in my answer because the square root of 100 is 10. It's a perfect square. So I'm going to rewrite this two ways. I'm going to rewrite this as negative 4 plus 10 divided by 2. And I'm going to write this as negative 4 minus 10 divided by 2. So on this left-hand side, what is negative 4 plus 10? Negative 4 plus 10 is what? Positive 6. So this is 6 divided by 2. What does x equal over here? 3. Good. And then over here I have negative 4 minus 10 is how much? Negative 14 divided by 2 is negative 7. Good. So here your two answers, and we knew there was going to be 2 from the very beginning because what's your highest exponent? 2. That's going to tell us how many answers we have. Your answer is positive 3 and negative 7. So sometimes you get nice pretty answers when they ask you to use the quadratic formula. What that means, that those are two whole numbers, is from the beginning it would have factored. So if it just says solve, you can do whatever you want. You can solve by factoring, completing the square quadratic formula. If it tells you specifically how to solve, then you have to do that specific method. So like right today, we're talking about the quadratic formula. So let's look over here at number 2. How's number 2 a little bit different from the first one? It's not in standard form. Good. Think about it, guys. You want everything on the same side set equal to 0. So what am I going to do? When I move this negative 3 over here, what does it become? Positive. Very important because if you don't have your signs right in the formula, it's going to mess everything up. So let's go ahead and rewrite it in standard form. 2x squared minus 7x plus 3 equals 0. So now we're in standard form. X squared, x constant, set equal to 0. So can we now say what our a, b, and c terms are? Yes, a is perfect. A is 2. B is negative 7. And c is, what is it? 3. Okay. So let's go ahead and throw this into the formula. Tell me, negative what? Negative b. So I'm going to say negative 7. Some of you are going to say, can I just make that positive 7? Yes, you can. But I like to get everything in first, and then we'll do our simplifying. What comes after my negative b? Plus or minus, because I have how many answers? 2. Good. Plus or minus the square root of b squared. So negative 7 squared minus 4 times what? 2, which is my a term, times 3, which is my c term, all over 2 divided by what? I'm sorry, 2 times what? Yep. Multiply by our a. Take a second to check signs. Just make sure you have everything inputted correctly. And now let's simplify. A negative gives me a what? Positive. So 7 plus or minus, big square root. What is negative 7 squared, guys? Positive 49. Good. Then I have minus. What is 4 times 2? 8 times 3. 24. Good. All over. 2 times 2 is 4. Very good. All right, we're going to keep simplifying. You guys are doing great. So I have 7 plus or minus. What is 49 minus 24? 25. Over 4. Good. Can I simplify anything there? What's the square root of 25? 5. Do I have any radicals left in my answer? No. So that means I have just 2 basic math problems that I can simplify here. What are my 2 basic math problems? 7 plus 5 divided by 4 and 7 minus 5 divided by 4. Good. So on the left-hand side, guys, what is 7 plus 5? 12. And 12 divided by 4 is good. So x equals 3. And then on the right-hand side here, what's 7 minus 5? 2. And 2 divided by 4 is x equals 1/2. So again, this one would have factored from the beginning, but we're not using factoring right now. We're using just the quadratic formula. 90% of the time when the question says use the quadratic formula, you're going to get a gross answer with a radical and all that stuff. That's why. Because like I said, if you are solving quadratics, the most direct and easiest way to do it would be to just factor, but not all of our problems factor. All right, let's move along here. Let's do 3. Evaluate the situation. Can I just go ahead and name my A, B, and C right now? Yes or no? Yeah, because we're in standard form, we're set equal to 0. So what's A? A is 1. What's B? -4, good. And what's C? 2. All right, so let's go ahead and throw it in the formula. X equals negative B. So -4 plus or minus the square root of what? -4 squared minus 4 times what's A? 1 times what's C? 2. And we're going to divide all of that by 2 times A, which is 1. All right, let's simplify. A -4 gives me 4. Plus or minus. What is -4 squared? 16. Positive 16. Minus, what's 4 times 1 times 2? Yep. All over. 2 times 1 is 2. All right, keep simplifying. Each step we get a little more simplified, a little smaller. So I have 4 plus or minus. What is 16 minus 8? 8 over what? 2. Okay. Does anybody know the square root of 8? Is there a perfect square hidden inside of 8? Yes. We cannot leave, guys, any perfect squares under radicals. We've been breaking down radicals from the very beginning. So I'm going to rewrite this as 4 plus or minus. What can I break 8 into? 4 times 2. Good. What's the perfect square that's hidden in there? The perfect square. Okay, so we're going to take the perfect square of 4 is 2. So this is actually 2 square root of 2 over 2. Now here's where we're going to make some silly mistakes. Some of you are going to say, well, these 2's cancel out. Is that the case? Can you just randomly cancel when we have plus or minus signs in numerators and denominators? No. What you guys need to get in the habit of doing, and Mr. Rodriguez and I were just talking about this earlier, we've got to get in the habit of splitting your fraction apart, because there's actually 2 2's in the denominator. There's 1 underneath the 4, and there's 1 underneath the 2 square root of 2. You just don't see it because when you have the same denominator, you can combine the numerator. So you guys need to get in the habit of pulling it apart. And now you can see how it simplifies. What is 4 divided by 2? 2. And then what happens with your 2's on the square root of 2? They cancel. So this would be your final answer.
That was a -4.
At the very beginning.
Yeah.
Yeah, see how your B term is already negative, so when you have the 2 negatives, it makes it a positive. Now, guys, where you guys are going to go wrong on web assign? All right, web assign, there is no plus or minus button, so you're going to have to enter it in as 2 plus the square root of 2, comma, 2 minus the square root of 2. They also don't let you put, they would not, if this were the final answer, you would not be able to put it like that. They're going to make you pull it apart to simplify it, so it'll get you in the habit of doing it. Question? Brady, question?
So you can, when it's attached to a radical, you can still cancel it.
Mm-hmm. As long as the number's on the outside. Yep. All right. Let's skip 4. Another one. Let's do 6. What's going on with 6? It's not in standard form, right? I need to rewrite it so it says x squared x constant equals 0. So when I bring this negative 2x over to this side, what does it become? Positive. Remember, we go over equal signs, our signs are going to change. So 2x squared plus 9x minus 5 equals 0. Can you now identify your A, B, and C terms? Yes. A is 2. B is 9. Good. And C is -5. Perfect. So let's do our quadratic formula. Negative B. So -9. Plus or minus the square root of b squared, so 9 squared, minus 4 times a, which is 2, times c, which is -5, all divided by 2 times a, which is 2 times 2. Once you guys get that into your formula, it's just a matter of simplification. Don't try to do too much at once. Don't try to do too much in your head. Just take your time. So we have x equals -9 plus or minus. What is 9 squared? 81. Good. -4 times 2 times -5. A negative times a negative is a positive. Good. So what is 4 times 2? 4 times 2? 8 times 5. 40. Good. All over 2 times 2 is 4. All right, keep simplifying. -9 plus or minus. What is 81 plus 40? 121 over 4. Does anybody know anything about 121? It is a perfect square. What's the square root of 121? 11. So what does that mean about my answer? Am I going to have any crazy radicals in it? No. Just means I have two. I'm going to simplify fractions. I have -9 plus 11 over 4. And here I have -9 minus 11 over 4. So on my left-hand side, guys, what's -9 plus 11? 2. So x equals how much over here? 1/2. Good. And then on the right-hand side, I have -9 minus 11 is -20 divided by 4. X equals how much? -5. Good. A quadratic formula is very, very straightforward. It's just a matter of making sure everything is in the correct form before you start, and then checking your signs.
I said the last equation we did, it was minus like 15 minus 8, but here it was 81 plus 40.
Because here you have a -4 times a -5, so a negative times a negative is going to give you a positive. Ooh. Yep. About the last one or? Okay. Good question. All right. What's wrong with 7? Fractions. Immediately this becomes harder. We just skip it, right? When I tell you about fractions, they are now our friends. We talked about how to get rid of fractions. What would I multiply, or what could I multiply this entire equation by to get those fractions to disappear? 6. Where'd you get 6 from? Common denominator. Very good. So look, guys, you can do anything to an equation as long as you're fair. What you do to one side, you have to do to the other. So I'm going to take a 6. I'm going to multiply it to everything. So when I say 6 times 1/2, well, what's 6 times 1? 6 divided by 2. 3. So I have 3x squared. Now I'm going to take this 6 and multiply here. What is 6 times 2? 6 times 2? 12 divided by 3 is... So plus 4x equals 6 times 1 is 6 divided by 3 is 2. All right. Can I go ahead and say A is 3, B is 4, and C is 2? Why not? Because it's not in standard form. That's where we got to be real careful, guys, because if not, if you don't move that, what is your C value actually? -2. Good. This is 3x squared plus 4x minus 2 equals 0. Now can I identify A, B, and C? Yes. Great job. So my A term is 3. My B term is, and my C term is? Great. All right, let's quadratic formula. X equals -b, so -4 plus or minus the square root of b squared, 4 squared, minus 4 times a, which is 3, times c, which is -2, all over 2 times a, which is 2 times 3. So as we simplify, -4 plus or minus, what's 4 squared? 16, good. I have a -4 times a 3 times a -2. A negative times a negative is going to give me a positive. Great. So 4 times 3 is 12. Times 2 is 24. Awesome. All over. What's 2 times 3? Great. Each time we simplify, our problem gets a little bit smaller. So I have 4 plus or minus. What is 16 plus 24? 40. Great. All over 6. Now, is 40 a perfect square? No. But can I break 40 into a perfect and non-perfect square? What? Perfect. 4 times 10. So when I simplify that, I have negative 4 plus or minus. What is the square root of 4? 2. So this becomes 2 square roots of 10 over what? Over 6. Now, what did I tell you we got to get in the habit of doing? We got to separate it. We got to pull it apart. So I'm going to rewrite this as negative 4 over 6 plus or minus 2 root 10 over 6. Can I simplify negative 4 over 6? Yes. What does that become? Okay. Negative 2 over 3 plus or minus. Can I simplify 2 over 6? Yes. 2 goes into 2 once. 2 goes into 6 3 times. So there's your, God bless you, simplified answer. Some of you are going to say, can I write it like this? Yes. Once you pull it apart and simplify, if the denominators are the same, you can rewrite the numerator over one denominator, but you don't have to. If you want to leave it separated, leave it separated. WebAssign wants it pulled apart. Just so you guys don't get confused on that. All right, let's look at 8. Okay, common mistake that we make is we set x equal to 0, we set x plus 6 plus 4 equal to 0. Can we do that? No, you cannot, guys. What do you have to do first? You got to distribute. Perfect. So x times x is x squared. X times 6 is 6x. And then I have plus 4 equals 0. Now, can I use the quadratic formula? Yep, let's do this one quickly. We're in standard form. We're set equal to 0. Let's go. What's your A term? 1. What's your B term? Perfect. What's your C term? Awesome. All right, so x equals negative b, negative 6, plus or minus the square root of b squared. So 6 squared minus 4 times a, which is 1, times c, which is 4, all over what? 2 times a, which is 1. Perfect. So let's simplify a little bit. Negative 6 plus or minus, what is 6 squared? 36 minus, what's negative 4 times 1 times 4? 16, good, all over 2. So negative 6 plus or minus, what's 36 minus 16? 20, good. Square root of 20 over 2. Square root of 20 a perfect square? No, but is there a perfect square hidden in there? Yep, what is it? Yep, 5 and 4. So as we simplify a little more, negative 6 plus or minus what? 2 square root of 5 over 2. And before I answer completely, what shall I do? Pull it apart, break it up. Good. So it's negative 6 over 2 plus or minus 2 root 5 over 2. So what's your final answer? Negative 3 plus or minus the square root of 5. Great. We like the quadratic formula because it's super basic, super straightforward. It's, hey, move everything to one side, get it in order, and then identify A, B, and C. Just plug in. That's all you have to do. Completing the square ones are a little more difficult. I understand that. What do I have to do? What could I multiply this entire equation by?
12.
I could multiply by 12, yep. Does it have to be 12? Could you have done 24? Could you have done 36? You can do any number that would be a common denominator. It's just easiest if you do the least common, so you have less simplification. But the only step we have to do here is multiply. 12 times 1 is, God bless you. 12 times 1 is 12 divided by 4. So 3x squared. 12 times 1 divided by 3 minus 4x equals 12 times 1 is 12. Divided by 12 is 1. Before I can throw this into the quadratic formula, what do I need to do? I got to move that 1 over. Good. That positive 1 on the right side becomes what on the left-hand side? Perfect. 3x squared minus 4x minus 1 equals 0. What's your A term? 3. What's your B term? And what's your C term? Perfect. All right. What about here? Well, I'm going to distribute. I know I'm working with quadratics, so my highest exponent should be x squared. 3x times x is 3x squared. 3x times negative 2 is minus 6x equals 3. And what do I need to do with that 3? 1 sec. What do I need to do with that 3? Move it on over. So when positive 3 moves to the other side of the equation, what does it become? There you go. Minus 3 equals 0. What's your A term? 3. What's your B term?
Minus 6.
And then what's your C term?
Minus 3.
Perfect. Good. Okay, yesterday's lesson was completing the square. And I know some of you watched the video, some of you didn't, but I just want to go over a couple of examples with you so you're aware of the steps, just to make sure we know. Again, this is a quadratic. So if the problem says solve, I'd first try to factor. Then if it doesn't factor, you can either use completing the square or the quadratic formula. So if you look at something like this example here, if we're going to complete the square, what do I have to do first with that negative 6? What was the first step yesterday? Anybody? Let me refresh your memory. When we're going to complete the square, the first thing you want to do is look to see what your A term is. If your A is a positive 1, if the number in front of x squared is positive 1, you're good to go. So have that situation, right? X squared, the number in front is positive 1, we're good. So the first thing we're going to do after that is to move the constant to the other side. So we're going to rewrite this as x squared minus 3x, and then we're going to put plus a big square equals, when I move negative 6 to the other side, what does it become? Positive 6, and I'm going to put plus a big square. Because, guys, what you do to one side of an equation, you have to do where? To the other. All right, so the process has begun. I look to see first, x squared is a positive 1, we're good. I move my constant to the other side. Okay, perfect. So now you're going to take your b term. Your b term is the one that is in the middle that has just the x. You're going to take your b term. What is your b term there? What kind of 3? Negative 3. We're going to take our b term, negative 3, and divide it by 2. That is what is going to go in your binomial over here. You're going to bring down that x, put it here, and then you put the negative 3 over 2 here, and you're going to square it. We're completing the square. I'll explain to you in 1 second what that means. Now, how do I know what's going to go in my box on each side of my equation? I have to square this. When I square, I go to the top and to the bottom. So what's negative 3 squared? Positive 9 over, what's 2 squared? 4. What you do to one side of an equation, you have to do where? To the other. So 9 over 4 goes here. Those 2 squares that you have on either side, those boxes, they will always be plus, because when you square a number, it always becomes positive. What you guys just have done is this trinomial here is now a binomial squared here. Those two things that I have in yellow are equivalent. They're the same thing. But because it doesn't factor pretty or anything like that, you have to do this process called completing the square in order to be able to solve for x. So now we're going to say equals. Well, if I'm going to add these two numbers together, what do I have to have? Common denominator. What's my common denominator between 1 and 4? 4. So if I multiply the bottom here by 4, then I have to multiply the top by 4. What's 24? Sorry, what's 6 times 4? 24. So now we can combine. What is 24 plus 9? 33. All right. We've already done problems like this. A couple days ago, we started off with a binomial that was squared. How did I get that squared to go away? What did I do to both sides? Take the square root. Okay, so if I take the square root to this side, I'm left with x minus 3 over 2. If I take the square root to the other side, what goes in front of my answer? What is it? Plus or minus. Do we know the square root of 33? No? Is there a perfect square hidden in there? No. So square root of 33. Do I know the square root of 4? What is it? Perfect. And then what's the last step that I need to take in order to get x all by itself? We're going to add 3 over 2 to both sides. So plus 3 over 2. Now again, you can write this either way. I like to have the plus or minus in the middle. I don't like it at the front. So I'm going to rewrite this as 3 over 2 plus or minus the square root of 33 over 2. If you were to use the quadratic formula, you would get the exact same answer. If you're not a fan of completing the square and the directions don't say solve by completing the square, then you don't have to. But for your web assignment homework, when it says solve by completing the square, that's what you need to do. If it says it on a test or a quiz, that's what you need to do. Yeah.
Test or quiz is good to be specific, like every time.
Probably. Mr. Saldana will probably do, if there's 10, There might be like 5 that just say solve, and then one that says solve by factoring, one that says solve by, just so you demonstrate that you know how to do it all. All right, let's do this other one right here. Sometimes there's situations that lend themselves to completing the square. All right, completing the square can be quick if the equation is set up in a certain way. What I mean by that is the first thing we look for, is my A term a positive 1? Yes. What do you notice about the B term? What kind of a number is 2? Is it odd or even? It's even. When your B term is even, completing the square is pretty easy because you take the B term, which is 2, and what do you do to it? You don't square it yet. You got to divide it by 2. So once I move this over, I have x squared plus 2x plus a big old square equals, when I move negative 5 to the other side, what does it become? Positive 5 plus a big old square. So look, when you take an even number and divide it by 2, you get a nice pretty whole number. You don't have to worry about fractions or anything. So I know that on the left-hand side of my equation, what is going to go in my binomial? What goes in the front? What letter? X, good. What number is going to go in the back? Positive 1, and we're going to square it. And then how do I figure out what number goes in each square on each side? I'm going to square that number. What's 1 squared? 1. What you do to one side, you do where? To the other. What is 5 plus 1? 6. And now we're back to 1.4a. I have a binomial squared set equal to a number. How do I solve it? You take the square root of both sides. So this becomes x plus 1. When I take the square root of both sides, what goes in front of my answer? Plus or minus, good. Is there a perfect square hidden inside of 6? Nope. So what's the last thing I have to do to get x all by itself? Subtract 1 from both sides. So x equals negative 1 plus or minus the square root of 6. Now again, if you use the quadratic formula, you would get the exact same answer. All right.